Hey everybody, Trey here. Welcome back to another forecast discussion. We've got a few days of severe weather coming up. We've been in a little bit of a lull here recently after an extremely active March into very early April. But we are picking that severe weather trend back up. For today, we have a slight risk. SBC has put out a slight risk, level 2 out of 5, from southeast Nebraska into much of central and east central Kansas into far northwest Oklahoma, surrounded by a large marginal risk. We do have a marginal risk out to the east as well for parts of Virginia, North Carolina into South Carolina. Going to be focusing on the more substantive severe threat today, which is that plain severe threat. Going to be a damaging wind threat and large hail threat today. Tornadoes not really going to be on the table for today, but we do have a significant damaging wind threat there from southeast Nebraska into central and south central Kansas, as well as a large hail threat a little bit farther to the southwest for central Kansas into northwest Oklahoma. Then tomorrow becomes the more substantial severe threat. We have an enhanced risk, level 3 out of 5, for basically centered on central Arkansas, including places like Little Rock, and it does include some places like far southern Missouri into northern Louisiana. We do have an all hazards threat for tomorrow. Tornado threat is on the table, 5% there from northern Arkansas into northeast Louisiana, far western Mississippi. Damaging winds also going to be a threat, and large to very large hail. Significant hail threat there from far southeast Oklahoma, northeast Texas, into the western half of Arkansas and southwest Missouri. So, potent couple of days on tap. We do have a severe threat for day 3, slight risk there for the southeast. We're not going to be touching on this in this video. More going to be what it looks to be more of a damaging wind type threat with some Boeing line segments, but we're going to focus on today's threat, the slight risk across the Central Plains, and tomorrow's threat, the enhanced risk across parts of Arkansas tomorrow in this video. So let's go ahead and get started. Let's take a look at our water vapor satellite imagery. Very interesting looking water vapor satellite imagery here. You see this very tight swirl out here across the southeast. That is an upper low that has been sitting across the northern Gulf and finally has ejected inland over the last couple of days. This has been a little bit of a bugaboo as far as moisture return into the plains goes. We're still struggling with that moisture return this morning. We're only seeing 60s dew points into Texas. We'll take a look at that in a second. But this has been sitting there over the Gulf, has moved inland and has moved away. And now we have started that process of really getting that moisture into the plains. Ahead of this trough here, you see this wave here. This wave feature there across the western half of the country. That is our next wave that will be our severe weather maker for today and tomorrow. If we look at our upper air maps, this is at 500 millibars, so about 18,000 feet in the atmosphere. Where we look for our jet stream, you see that closed low out across the southeast. Again, that is moving off to the northeast away from the region and is going to be replaced by this very large high amplitude feature digging into the southwest at the moment. Very broad high amplitude feature. This is not your tightly wound compact trough. So we could have a broad area of severe threat. Today, that is going to be mitigated a little bit by some thermodynamics issues, but tomorrow we could have a widespread severe threat as we saw on the day 2 outlook from this trough. So very high amplitude feature, not super strong winds associated with this trough. A lot we do see on the backside, about 50, 60 knots or so maybe, but that's about it. That's your strongest wind still located on the backside of this trough, so it is still in the process of maturing and will do so over the next couple of days as it ejects into the plains into the southeast. But not overall strong flow aloft, but we still do have that southwesterly flow traversing the Rockies here, and as a result we have seen a little bit of a response out to the east. We have a broad 850 millibar cyclone here, and is associated with a low-level jet extending up from the Great Lakes states, Minnesota and Wisconsin, down to the south into the southern plains, 30, 35, 40 knots or so of flow there out of the south-southwest. That is going to have a little bit of an implication on today. The low-level jet is out of the southwest, and, well, where's our source region for that air? It's out here, and it is some pretty dry, well-mixed air. We'll look at some soundings here in just a second, but this likely will play a role, at least in the southern portion of the target today, for the mitigation of storm initiation, especially across Oklahoma into North Texas, where a couple days ago it was looking at least somewhat likely that we might see storms across that area. SPC has taken that risk area out, as you see for today, just a general thunderstorm risk extending into southwest Oklahoma, nothing into Texas. A few days ago, that was not the case. We had a risk all the way down into Texas as we thought. Storm initiation might be a little bit more likely, but given the timing and placement of the trough and this southwesterly low-level jet here into the southern portion of the target, really has just blow dried this area with a very steep elevated mixed layer. We'll talk about that again in a second. Surface reflection here. We do have a surface low that has developed across eastern or western Kansas, 998 millibar low there. Another low center up here into Minnesota. This is all along some sort of frontal zone here. Looks like a cold frontal zone. This will continue to sag southeastward as we go through the day today, and will be our initiating boundary for storms across southeast Nebraska into eastern Kansas. Areas away from this surface low and cold front will be away from those forcing mechanisms and thus will not be able to overcome that capping that we'll talk about here in a second across that southern portion of the target. So let's go ahead and look at our surface map. Let me refresh this here. So you see what we've talked about here with the moisture. 60s dew points only up here to about north central to central Texas, and that's about it. But that's because we've had that upper low just situated across the coast, the Gulf Coast, for a while. And if you can imagine, let me go back to our upper air maps here. So we have this upper low. It has been associated with a surface low that has since kind of washed out or so. If we go back here, let me go back and pull up the SPC upper or surface maps. Let me do the upper air maps from yesterday, and you'll see that we have, I'll go to 925 millibars here, and let me go to the 3-day loop. So you'll see we've had this low out across the northern Gulf, and you can imagine around the low we have counterclockwise flow. Well, that flow out here is out of the north across the western Gulf Coast, pushing that moisture off, keeping that moisture out into the Gulf and not allowing it to get transported inland. And that has been a problem for the last couple days. That's why we're seeing this moisture so meager at this point, going to be somewhat just-in-time moisture. We do have 50s dew points all the way up into Kansas at this point, so the moisture may be a little bit more meager with northern extent for sure. We should get 60s dew points down here into the Red River region, into Oklahoma by this afternoon, but again, that probably will not be enough to initiate storms out here ahead of the dry line across Oklahoma into North Texas. But nonetheless, we'll have moisture transport that will be underway, that 998 millibar low into Kansas, strengthening that flow in the warm sector at least modestly and helping to transport that moisture northward, especially for tomorrow. We should have plenty of moisture in play for tomorrow, given that extra day to transport moisture in. Let's go a little bit farther north just to show you exactly where that surface low is. Now you see that frontal boundary pretty clearly by the wind shift. Northerly winds to the west of the boundary, southerly winds to the east of the boundary. Surface low situated somewhere in here. You can see that counterclockwise flow right in there. So surface low situated somewhere in there. And we should again have that dry line. We'll draw in green here. Dry line will set up somewhere probably across this region here, western Oklahoma into North Texas by this afternoon. We should have a dry line bulge. Sometimes that does help in allowing some extra forcing along the dry line, but today, again, that cap is going to be so strong, I don't think we're going to get storm initiation down here to the south, but we'll have a dry line in play. Cold front, surface low. Surface low is just going to meander a little bit into central Kansas by today, so the cold front will be moving a little bit farther to the south fairly slowly, but should have enough forcing to initiate storms as it moves off to the southeast in a relatively moist environment. 50s dew points up here into southeast Nebraska by this afternoon should be enough to initiate storms later on this afternoon. All right, let's take a look at some soundings. This is the Norman, Oklahoma 12Z sounding, and you can see exactly what we're talking about. Low-level moisture pretty meager here, 59 over 51 at this point. And you see this very stout elevated mixed layer here. Again, the elevated mixed layer, we talk about it every video, it seems, on this channel. The elevated mixed layer, EML, is that layer of dry, well-mixed, warm air that emanates on the higher terrain of the desert southwest and western Mexico and gets transported out to the east atop whatever moisture there is in the low levels. And that can help prohibit storm development and allow instability to build in a given environment before it erodes. Well, it's got to erode for storms to fire, and that's going to be the problem today, especially in the southern portion of the target. This elevated mixed layer is very, very strong. The timing of the trough and the timing of the moisture return may be a little bit off as far as allowing storms to initiate in this environment today. Dallas-Fort Worth, much of the same thing. You see that very stout elevated mixed layer there over meager low-level moisture. Go down to the south here to look at the quality of the moisture coming up here at Brownsville. We do see a decent moist layer there, up to about 850 millibars, but man, that is a steep elevated mixed layer right there above 850 millibars. So that's going to be transported northward And given the timing of the trough, we'll look at that in a second. Just not seeing enough to initiate storms in the southern portion of the target, southern Oklahoma into northern Texas. But farther to the north, closer to those forcing mechanisms, the surface low, the cold front, that should be able to push parcels through this elevated mixed layer and allow storm initiation up there into Kansas and southeast Nebraska. Take a look at a Topeka sounding here. Still much of the same, very weak low-level moisture. Not quite as pronounced of an EML perhaps as farther south, but still you've got some of that in play. But again, those forcing mechanisms will be enough to initiate storms up there today into tonight. All right, let's look at some model data for today. This is the 12Z NAM, hot off the press. You see that 500 millibar upper low moving off to the northeast there, replaced by this trough down here. Very interesting. We have kind of two different jet streams here in play. We have our subtropical jet here, that belt of enhanced flow flowing into Mexico. Our more sort of Arctic jet here digging down into the western half of the country, and we'll have this big old trough here out to the west as a somewhat of a conglomeration of the two. So as we go on into today, that trough is going to move off to the east. Negatively tilted trough, but again, it's not a very compact, tightly wound trough. We do have that axis, if we were to draw that axis, somewhere in that vicinity. So definitely a negatively tilted trough, what we like to see. But again, that forcing is just a little bit farther off back to the west. So, a few days ago, we were seeing this trough a little bit farther to the east, which definitely would have helped to erode the cap. We talk about cap erosion a lot. You need some semblance of forcing to help erode that cap. If you have some type of trough like this, timed well, then you can have that capping inversion that will be lifted and cooled. And that's how you erode the cap. But this is a little bit farther back to the west, a little bit too far back to the west perhaps, to fully erode that cap here into the southern portion of the target. Once again, the northern mode is going to have some extra help from the cold front and surface low. But down here into Oklahoma and Texas, the forcing is just a little bit too far back here to really fully erode the cap as we go into today. But as we go into the evening, the trough continues to move off to the east. We'll have plenty of forcing there across the northern mode. Should stay quiet here across the southern mode because of that cooling. After dark, we should have that cap grow rapidly back in, although it won't really fully erode as we said throughout the day. So that cap will just increase throughout the evening. So we should still remain quiet here across the southern portion of the target. But northern mode still within that forcing should have a conglomeration of storms up there into Nebraska and Kansas. Let's go down to 700 millibars. We've been watching over the past couple of days a little bit of a shortwave that has been progged by models that was perhaps going to be of assistance to this southern portion of the target. Now, if we go on here, you do see a little bit of a kink in the 700 millibar isobars, height contours there. A little bit of a kink maybe there, very subtle. This is at 21Z, 4 p.m. Central Daylight Time. This is really, really subtle. And again, we're going to have to watch. I think there is a non-zero chance of storms forming here in western Oklahoma, northwest Texas. But again, I think it's very, very low. But we do have this shortwave here that may be inching its way through. It was a little more pronounced on previous runs. This is the 12Z run from yesterday. You see a little bit stronger flow associated with this little kink right here. And so that was maybe added a little bit more to the confidence that we had yesterday and the previous couple of days in storm initiation farther to the south. The NAM has definitely backed off on the strength of this shortwave, so not looking like that's going to be enough to initiate storms there in the southern mode. So even though we do have that shortwave trough maybe a little bit showing up here on the 700 millibar map, I don't think it's going to be enough to initiate storms here in the southern mode. Won't really need it in the northern mode again because of those forcing mechanisms at play already. Low-level jet here, 850 millibars. You'll see we have that low-level jet really decrease throughout the day here. So low-level shear should be fairly weak across the northern mode, hence the lack of a tornado threat across the region. We should see some semblance of that low-level jet increase as we go into the nocturnal hours, as is usual. Again, won't really matter in the southern mode, southern portion of the target, Oklahoma, Texas. We won't have storms that will impact, but to the north, low-level shear will be increasing as we go after dark. That may lead to a conglomeration of storms into more of a cluster or linear mode. We go down to the surface here, and you'll see that surface low in Kansas here just kind of meanders throughout the day. You'll see it doesn't move a whole lot. It actually kind of sags to the south a little bit as that cold front pushes south. You'll see that cold front boundary there, the greens, the cooler temperatures, the yellows, oranges, and reds, the warmer temperatures, So your cold front boundary is situated right in there. Surface low down here. Sags to the south a little bit throughout the day. And so as that cold front pushes through, you'll have some forcing along it. Storms should fire there by mid-afternoon along that cold frontal boundary and maybe closer to the surface low center down here in southern Kansas. We go through with time. That cold front continues to sag south, and that cold front will be a player tomorrow for tomorrow's severe weather event. Moisture, you'll see, is quite just in time, as is expected, as we looked at with our surface data. Let me zoom in here real quick. So you'll see those 60s dew points still situated well to the south across Texas here at 12Z, 7 a.m., as was initialized by this model. They are rapidly advecting northward as that surface low pushes, develops and tightens here a little bit throughout the day. You'll see that those 60s dew points, at least on the NAM here, actually make it up pretty far north up here into the Kansas-Oklahoma border by 21Z, 4 p.m. Central Daylight Time. So very rapid moisture advection here, a little bit more rapid than I thought. And you'll see that dry line bulge here. The dry line sets up here across central to northwest Texas. That is a very, very tight dry line. We should see some strong convergence along it. That's why I think we still have a non-zero threat here. You'll see the winds to the west of the dry line out of the southwest, southeasterly winds to the east of the dry line. That is a pretty strong dry line there. Very tight as well. The moisture gradient you'll see is extremely tight there. We go from dew points in the low to mid-20s to mid-60s dew points here out across Texas into southern Oklahoma. So again, I think there's a non-zero chance of storm formation here. You have this dry line bulge as well, a little bit stronger convergence right in here. So if there was any spot in the southern target that was going to initiate a storm today, I would expect it to be somewhere here in northwest Texas, right here, Weatherford, Bowie, Decatur, down to the southwest. Would expect to see that as the favorite area for storm initiation, if we can get storm initiation later on today. You do see the northern mode. Let me shift sectors here real quick to the Central Plains sector. You see that moisture, very minimal with northern extent here. We just don't have enough time to get those 60s dew points up into southeast Nebraska. But we do get them up into Kansas as that cold front pushes southward. This is at 0Z, 7 p.m., 3Z, 10 p.m. So we should see storms here, again, mostly probably given a large temperature dew point spread, given the very limited moisture up to the north. Should see more of a large hail and damaging wind threat up here. Let's take a sounding here at 0Z out ahead, northeast Kansas. And I want to take one down here as well along that dry line bulge, just to show you how that cap may remain entrenched in the region. So this is farther to the north, as you can see, well-mixed low levels, 78 over 58. I think that might be a little bit too cool there at the surface. We do have full sunshine. If we look at our visible satellite here real quick, full sunshine here throughout the day. So we should get temperatures very, very warm up to the north as well. So I think this is a classic NAM underdoing the surface temperatures just a little bit. So that would make the temperature dew point spreads a little bit large. Again, the larger the temperature dew point spread, the less the chance for tornadoes. Tends to be more of an outflow production increase when you have larger temperature dew point spreads. We do have very strong instability here throughout the column, about 2,500 joules per kilogram of mixed layer CAPE. Atop a well-mixed moist layer, uncapped sounding here. Very short photographs. Effective bulk shear is only about 30 knots. That's really on the margins for supercells. That's due to that fairly weak flow in the mid and upper levels here. You don't even see a wind barb on this sounding reach 50 knots. That's pretty unusual for this time of year, especially with a trough coming in. But that has allowed these photographs to be fairly short. So I think we may see a mixed mode type event, more of a mixture of multicells, maybe some transient supercells in here. 30 knots is right on the margins, kind of on the low side. So we should see a mix of multicells and maybe a couple supercells embedded in there with a large hail threat, given somewhat weak low-level shear and a damaging wind threat. We should be able to get some damaging gusts due to enhancement of evaporative cooling, given the large temperature dew point spreads and dry low levels. But this is a nice sounding for some hail and damaging winds up there in the northern target. We go farther to the south, and you see that cap remains entrenched into the region. We do get a little bit better moisture, as we saw, 74 over 64 here at the surface, but it is fairly shallow, definitely below 850 millibars. That cap staying very, very strong. Just doesn't look like that convergence along the dry line and the maybe subtle shortwave moving through is going to be enough to get storms to fire in this southern target today. But we'll have to keep an eye out. That dry line, you never want to pass up. You never want to take your eyes fully off a dry line like this in the middle of spring across the plains. So let's go ahead and look at some convective allowing models here. We'll look at some cams, and we'll start off with the 12Z HER, and we'll see what happens here. So this, as we go into the late afternoon, you get some storms to fire there across even far northwest Oklahoma, central Kansas, up into Nebraska there. Again, nothing looks really amazing. We do see some stronger cores in there. Not really a mixed mode type threat, supercell, maybe a couple supercells with mostly a multi-cell mode up there. Large hail damaging winds threat. You don't see anything farther to the south. That cap remains strong down there. Let's look at maybe a couple others here. We'll do the ARW just to see. And you see storm initiation there across Kansas and Nebraska. Quickly transitions to a more linear mode. Very outflow heavy storms. You see that outflow boundary out ahead of the storms pushing out. That is indicative of strong outflow, as is expected in this kind of thermodynamic environment. Nothing farther to the south. NSSL WRF. Just let's see here. And you'll see it does fire storms up there across the same area. So pretty good agreement among the convective allowing models, as that goes along with our forecast of a mixed mode event quickly transitioning to a messy mode later on into the evening. Some large hail damaging winds with these storms. All right, let's go back and look at our threat for tomorrow. Let's go ahead and zoom back out to the continental U.S. sector. We'll go to 500 millibars once again. So this trough undergoes some changes as we go into tomorrow's event. You'll see it goes, again, not a lot of strong wind associated with this trough here. But as we go into tomorrow, that's going to change. It's going to start digging down and really amplifying a little bit. And we do have this broad belt of strong flow rounding the base of this trough. Relatively compact trough with a well-defined exit region here. Strong defluence aloft. If we were to go up to 250 millibars here, you'll see in the exit region of this trough, very strong defluence aloft flow there over northeast Kansas out of the due south, across Arkansas there over the west-southwest, out of the west-southwest. So very strong defluence aloft. That's the spreading apart of those wind vectors in the upper levels of the atmosphere, creates a void. The atmosphere doesn't like that, so it brings up air from below to fill that void. And that's how we get large-scale or synoptic scale rising motion to set the stage for storm development in a given environment. Very strong look to this. And this is a pretty solid look, pretty solid looking trough if you're looking to see some significant severe weather across this area. Takes on that negative tilt with time. Starts off somewhat positively tilted or neutrally tilted. Takes on a little bit more of a negative tilt as we go into the evening hours tomorrow. This is a pretty solid looking trough, I have to say. Let's go down to 850 millibars, and the low level response is going to be a little bit limited. Weirdly enough. So you'll see this go on. We just have this broad 850 millibar cyclone. Not a whole lot to speak of as far as low-level jet in the open warm sector there. We do have some elements of 30, 40 knots there, but interestingly, we don't have a very robust low-level response. For some reason here, if we look at our surface map as well, you'll see that surface low across sags into western Oklahoma by this evening. We go into tomorrow, that moves off to the west. That cold front shifts off to the east. We do see some stronger surface low development a little bit there into Missouri. That may be a favored location, a little bit more for an enhanced tornado threat up there in central to northern Missouri, closer to that surface low. That cold front pushing east, we should have storms ongoing along it in the morning. We'll have to watch as well for open warm sector development, as we should have a broad enough warm sector for that to occur. We'll stay with the CONUS sector. So that moisture gets up into Kansas, into Missouri by tomorrow morning very easily. Broad warm sector out across this region. Progressive cold front, so storms should be ongoing along the cold front. But this warm sector does look wide enough for maybe a few storms out ahead of the main line. Let me zoom in here a little bit. We'll go to our Midwest sector here. And I want to look for any prefrontal confluence bands here. We do see a little bit of something maybe in here, little bit of a prefrontal trough out ahead that we'll have to keep an eye on for open warm sector development. You see some slight confluence here as well. These particular wind barbs out of the south-southwest, more southerly winds here, so perhaps a little bit of a confluence band here out across eastern Missouri into northeast Arkansas. We'll have to watch that for sure as we go into tomorrow. A little bit of a stronger surface low development there in northwest Missouri. This could be convectively enhanced, but we'll look a little bit deeper here in a second. But moisture definitely gets up into the region. Moisture not going to be an issue for tomorrow. Very progressive cold front, as we said, with that trough strengthening. That should push that cold front off and the surface features off pretty quickly to the east. let's go ahead and take a sounding here. We'll take one out here in southwest Missouri, maybe one up here into north central Missouri right near that warm front, maybe one down to the south across Arkansas. How about Little Rock right there as well? So this is at 18Z, so fairly early. We should have some capping inversion as according to the NAM here in play, at least farther to the north. Same here, a little bit farther to the south, same thing. Our wind profiles, though, remain fairly weak throughout much of the morning and early afternoon. You can see a little bit of wonkiness there. Very weak low-level winds, which is very unusual. Perhaps just the progression of the trough coming in a little bit weaker and really taking shape across the central portion of the country, not really farther back to the west where that stronger flow can traverse the Rockies, produce stronger Lee cyclogenesis. We don't really have that here. So the low-level response is going to be somewhat muted with this incoming trough, which is somewhat unusual. Let's go a little bit farther into the future. Let me go up here once to the northern mode. I'll take one right here on the warm front where shear may be a little bit more enhanced. And then let me go a little bit farther to the south and take a few soundings here. So we'll take one there across Arkansas as well. So this is the northern portion of the target. And you do see that cap is eroded by 21Z, 4 p.m. Central Daylight Time. Very strong-looking thermodynamic profile, almost 3,000 joules per kilogram of mixed layer CAPE. Very strong low-level CAPE as well, 0 to 3 kilometer CAPE approaching 160 joules per kilogram. So the thermodynamics here are very, very impressive. But look at our photographs. Very short photographs with not a lot of curvature there in the low levels. Only about 120 meters squared per second squared of effective storm relative velocity, only about 35 knots of effective bulk shear. So once again, we're somewhat on the margins for supercells, a little bit stronger than what we'll see today. So I do think supercells are a little bit better of a bet tomorrow. But given this favorable thermodynamic profile, weak low-level shear, and if we can sustain some supercells, some large to very large hail will be a threat given this thermodynamic profile. Very impressive thermodynamics here with this event. Farther to the south, instability is even better here, over almost 3,200 joules per kilogram of mixed layer CAPE, and 0 to 3 kilometer CAPE approaching 150. So very strong thermodynamics across the entire warm sector. But once again, struggling to really get robust photographs here. I think that should keep the tornado threat at bay somewhat, given that we have strong low-level CAPE, low-level instability. Any spin in the low levels along surface boundaries could, or maybe any prefrontal confluence bands could allow for a maybe slightly greater tornado threat. But these photographs are not super favorable for a significant tornado threat. Not a lot of curvature there in the low levels. Weak flow once again in the low levels there. And deep layer shear only about 33 knots. That's still on the margins for supercells. So perhaps a mixed mode event tomorrow as well. I do think supercells are a little bit better of a bet tomorrow. Let's take a look at 0Z. We'll go back up here to our northern mode, up here into maybe up into the St. Louis or Kansas, St. Louis area, excuse me. And then we'll go down here to the south. We'll do southern Missouri-Arkansas border, and maybe one more down here in a little bit farther south into maybe the Louisiana-Arkansas border. So to the north, wow, that is impressive actually. We do see an enhancement in the low-level shear. Deep layer shear still on the margins for supercells. Very weak low-level shear, mid and upper-level shear here. We do have some curvature there in the low levels, though. Some veering of those winds in the low levels. And my goodness, look at that 0 to 3 kilometer CAPE. 234 joules per kilogram of 0 to 3 kilometer CAPE. That is extremely, extremely impressive. So definitely going to have to watch out there farther north along that surface low track. 3,600 joules per kilogram of mixed layer CAPE. That is extremely impressive. So the thermodynamics in this event for tomorrow are not going to be an issue. It's the shear that is an issue. Only 32 knots of effective bulk shear. So supercells, again, are a little bit more questionable, a little bit more marginal deep layer shear for supercells. But if we can sustain some, which I think we will, man, this is some strong low-level shear, strong low-level instability. That would foster a tornado threat as well as a large hail and damaging wind threat as well. So farther down to the south, low-level shear is a little bit less away from the surface low. Again, kind of a wonky photograph there. Thermodynamics not really an issue. Farther to the south, wow, along the Louisiana-Arkansas border there, Arklatex region, this is equally as impressive as the northern mode. A little bit of low-level shear. Shear is a little bit stronger down to the south, 40 knots of effective bulk shear. Very interesting there. I wonder if that has something to do with a little bit, maybe a little bit closer to the trough up here. Maybe a little bit more of a low-level jet. We do see maybe a pocket right there. Maybe I think I pulled that right in there, that little pocket of 40 knots or so. So perhaps a little bit stronger shear farther to the south, but that thermodynamic profile is extremely impressive. 4,000 joules per kilogram of mixed layer cape with over 200 joules per kilogram of 0 to 3 kilometer cape. That is extremely impressive. So with this amount of low-level shear in place, despite somewhat weaker deep layer shear, although adequate for supercells, that could foster a tornado threat farther to the south that we'll have to keep an eye on, as well as a large hail threat and damaging winds. So very interesting setup for tomorrow. Again, we should have storms along the overall cold front as it progresses to the east. As we go back to our map, you'll see it does progress to the east pretty quickly. Sags a little bit more in a west, out of the southwest and northeast direction, farther to the south, a little bit more north-south here to the north. Could have some implications on storm mode. Let's take a look at that really quickly. We'll look at our shear vector orientation with respect to the initiating boundary. And you do see we do have somewhat of a component off of the boundary there. So we could have maybe a more broken line across along the cold front. Again, we'll have to watch out across Arkansas, southern Missouri into northern Louisiana for any prefrontal troughs. The NAM is showing some evidence of prefrontal troughing out in the open warm sector that could fire some supercells, more discrete supercells with a large hail and perhaps a tornado threat, especially a little bit farther to the south where instability is a little bit larger as well, and shear is a little bit larger, coinciding with that strong instability. Let's look at some cam runs for tomorrow. We'll go back to the 12Z HER and see what it shows. So we'll go into this evening. We'll have storms ongoing, especially to the north into the morning hours tomorrow. Then we'll have renewed development out here. We do see it maybe somewhat just ahead of the cold front there, northern Arkansas into southern Missouri. Definitely some stronger cores in there, some large hail expected, given weaker low-level shear at least to start. That is pretty impressive. A little bit of mixing there in the low levels. That could be a HER artifact. HER does like to over-mix the environment, dropping those dew points, heightening those temperature dew point spreads. There, it's just a quirk of the HRRR model, but that is strong instability as we saw on the NAM, strong low-level cape with some curvature in the low levels, 235 meters squared per second squared of effective storm relative helicity. So would have at least a marginal tornado threat to begin with, but a large hail I think is going to be the main threat. Then we see storms really conglomerate along the front as it pushes east, especially down to the south into Arkansas. Much messier up here to the north where the forcing may be a little bit stronger near the surface low and cold front. But we conglomerate pretty quickly, at least on this particular run, to a more messy linear mode. Let's go to the ARW. We'll see what it shows. So we go into tonight, storms ongoing into the morning, and we do see some development up to the north, very messy very quickly. Farther to the south, it's a pretty messy look here on the ARW, given some stronger forcing than we will see today. We could have a little bit more of a quick transition to more messy storm modes. NSSL WRF, again, we'll have to watch the open warm sector for any development that could be a little bit more discrete, but we get some development out here across from the Arklatex into Arkansas up to the north as well, but pretty messy storm modes. We do see maybe some evidence of supercells in there, more discrete updrafts in there, but a little bit hard to say at this point. As we know, cams this far out are not super trustworthy and should be taken with a grain of salt, but definitely an environment favorable for large hail, damaging winds, and maybe a few tornadoes, and that's why we have that enhanced risk for tomorrow. So that's going to do it for this video. Once again, for today, Friday, April 14th, slight risk is out from southeast Nebraska into central Kansas and northwest Oklahoma. Storms will fire along the cold front and surface low this afternoon into evening. Shear is on the margins for supercells, so tornado is not going to be a major threat, and the mode should transition to such where we should see a large hail threat initially, especially across central Kansas into northwest Oklahoma, and then a damaging wind threat as storms move off to the east and conglomerate a little bit more into more messy modes. Should be a mixed mode between mostly multicells and maybe a few supercells embedded in there. Those supercells will have a greater chance for severe weather, large hail, and damaging winds. Then we go into tomorrow, a little bit more substantive severe threat, enhanced risk level 3 out of 5 from southern Missouri into central Arkansas to northern Louisiana, surrounded by a large slight risk. All hazards on the table for tomorrow, as we saw. Shear is going to remain somewhat weaker as we looked at with some of those forecast soundings. But nonetheless, we should have very strong thermodynamics in play, which can sometimes overcome a little bit weaker shear. Where we do see a little bit stronger shear locally, we could have a greater tornado threat. We do have a 5% right now from northern Arkansas into northern Louisiana, western Mississippi, surrounded by a large 2%, damaging winds as well, centered there in that enhanced risk area, and large hail, perhaps very large hail, given strong thermodynamics at play, especially areas to the west, southeast Oklahoma, the Arklatex region, western Arkansas, into southwest Missouri. So that's going to do it for this video. Thanks for watching, and we'll see you in the next one.